Okay, so first thing is we want the derivative of this function for when hamburgers are sold. So that's 5 cos x. And we want to know when is it positive. So we nearly have 2 periods, but instead of stopping at 4 pi, we stop a little bit sooner. So there to there is 2 pi. That's pi. And then down to the bottom here, that's 3 pi. And then 4 pi, we don't quite get to the top. We kind of stop a little bit sooner at 12. So it's positive 0 to pi over 2. And then here to here. And then here to the end. So that's 0 to pi over 2. 3 over 2 pi to 5 over 2 pi. And then 7 over 2 pi, is it? To 12. I have the answers at the back. Yeah, that's it. Okay. Now we've got a tech question. I'm really tired because I didn't sleep well earlier in the week and I haven't felt like I've caught up. So I've just been carrying tiredness from day to day. So I really don't want to make any mistakes today. Okay. Let's see. Let's type this this function in. Yt is 0.5 plus 0.3 cos t. The amount of rainfall per month in Phoenix, Arizona is given by that, where t is months since January, and y dash. Well, what's the unit? Why do they not tell me the unit? So y is some mysterious unit for rainfall. Who knows? Inches, centimeters, furlongs. Find y dash and use a calculator to determine the intervals when the amount of rain falling is decreasing. Okie dokie. Whoops. And then when is it decreasing? I suppose I should put some bounds on it. But I think I can only do that if it's. I wonder if I put bounds on it, what will happen? Huh? It's weird. Let's plot this. And we'll go here. So, okay. And we're looking for decreasing. Decreasing would mean negative, so that's when it's under the axis. Okay, so I guess we don't have to solve it. You can kind of see it here. It's 0 to pi. Then, what's that? 2 pi to 3 pi? 0 to pi. That's a 2 pi. That's a 3 pi. And then 3 pi to 12. It's actually kind of similar to the last question. Yeah. Okay. I think that's all right. All right, calculate here using the quotient rule. So that's the derivative of cotan being cos over sine. So cos over sine derivative. So that's the bottom squared. The bottom times derivative of the top minus the top times the derivative of the bottom. Did I get that right? The bottom squared, the bottom times the derivative of the top. Oh, sorry, minus the top times the derivative of the bottom. So that's a minus 1 over sine squared. So that's a minus cosec squared. Here is the derivative of 1 over cos. I'm sure I did these earlier. 1 over cos. So that's then a cos squared. Bottom times derivative of the top minus the top times derivative of the bottom. Sine over cos is tan, and then 1 over cos is sec. So that's right as well. 207, I'll write it over here, run out of space. So the derivative of 1 over sine x, that's the bottom squared. The bottom times derivative of the top minus the top times derivative of the bottom. Cos over sine is cotan. Put a minus here. And then 1 over sine is sec. 1 over sine is cosec x. Now, use the definition of derivative and identity to prove the following. Okie dokie. 208. The derivative of cos x equals the limit as h goes to 0. Cos x plus h, which will be cos x cos h minus sine x sine h minus cos x all over h. That's going to be limit as h goes to 0. What do I want to do? Take out the cos x, I guess, and leave them with cos h minus 1 minus sine x sine h dot over h. Now that's the limit. I can take out the cos x because this has a limit. Limit as h goes to 0 of cos h minus 1 over h minus sine x times, and this one has a limit, h goes to 0 of sine h over h. That's a 1 and that's a 0. But I'm not sure if that one is in the book as one you can use. As like it's been proven in the book, cos x 0. And then this is minus sine x. I'm pretty sure this is in the book. I mean, I'm nearly certain this be in any calculus book. So that's minus sine x. Yeah. I don't know. If it's not in the book and people want me to prove it, I could prove this one here. Yeah. Yeah, okay. Right. Now we've got some triple derivatives to finish off on. (209). So y equals, so d3y dx cubed. So this goes cos, first derivative brings it to a minus sign, and then another derivative brings it to minus cos, and then another derivative brings it to a minus sign. So you actually just get 3 sine x in the end. But I can't be as quick for the next one. Let's just double check that one. Yeah. Can't be quite as quick for the next one. 210. So the first derivative, that's going to be 3 cos x plus product rule, 2x cos x minus x squared sine x. The derivative again is minus 3 sine x plus a product rule. 2 cos x minus 2x sine x. Product rule again. Minus 2x sine x minus x squared cos x. So, not really seeing much I can add together except the middle two here. Could make that a minus 4x sine x. That's about it. So now the third derivative will be minus 3 cos x minus 2 sine x minus 4 sine x minus 4x cos x minus 2x cos x plus x squared sine x. So let's do the x squareds for, maybe I should group it by trig, because actually, so the sine x would be an x squared cos minus 4 minus 2, so actually minus 6 sine x. And then the cos x's, minus 3 minus 4x minus 2x minus 6x cos x. Isn't that right? Minus 3 minus 4x minus 2x minus 6x, and then minus 2 minus 4 is minus 6 with the x squared. So the best I can do actually is x squared minus 6 sine x minus 3, 1 plus 2x cos x. I think that's as good as I can get for 210. 211, of course. So let's see. Let's keep track here. So cos, first derivative becomes minus sine. Second derivative becomes minus cos. Third derivative becomes sine and cos. So it's actually still equal to 5 cos x. Yeah. Oh man. Okay. That one looks a little messy. Let's make some space here for the last two. Okay. Y equals sec x plus cotan x. Now maybe I want to simplify it first. Y equals 1 over cos x plus cos x over sine x. Maybe I don't want to simplify it. Do I? Maybe not. Okay, so the first derivative would be the bottom squared, the bottom times the top minus the top times the derivative of the bottom. And then here, the bottom squared, the bottom times the derivative of the top. It's the minus one again. Yeah, so do I want to combine them before I differentiate? I don't think I do. Do I? Cos squared, sine cubed minus cot. No, maybe I should just push on. So then the second derivative would be the bottom squared, the bottom times the derivative of the top, so it's cos cubed, minus the top, which is sine x times the derivative of the bottom, which will be 2 cos minus sine, using the product rule actually. 2 cos times minus sine. So that becomes a plus then. And then this one here, the bottom squared, bottom measure at the top, minus the top, which is minus 1, so that's plus 1, times the root of the bottom, which is 2 sine cos. So get rid of a sine here to make it a 3. You can get rid of a cos here to make it 3 as well. But they're still different denominators, sadly. Nothing I can do, really. Nothing I can do. Cos squared x plus 2 sine squared x over cos cubed x minus 2 cos x over sine cubed x. I could change 2 sine squared into 1 minus cos squared. That might be better to simplifying this. So then you'll have 2, and then cos squared minus 2 cos squared is 2 minus cos squared x over cos cubed x minus 2 cos x over sine cubed x. But kind of inclined just to leave it like that. I can reintroduce sec, cotan, and so on, but really not really inclined to. Because you could change this into 2 minus cos squared x. Or I think what they normally like to do is to divide in the cos. So 2 over cos would be 2 sec x. Yeah, actually, maybe we'll split it up and simplify it a bit more. 2 over cos cubed x minus 1 over cos x minus 2 cos x over sine cubed x. So you could change that to 1 over cos is sec x. We'll just go with sec cubed x. And then this would be sec x. And then cos over sine is cotan x. But then it's 1 over sine, which is cosec squared x. Yeah, we'll leave it like that. Okay, and lastly, 213. What are we doing for sound? Are we still recording? Yeah, okay, nice. Y equals x power 10 minus sec x, which is 1 over cos x. So the first derivative is 10 x power 9 minus, and then the bottom squared, bottom times the top, minus the top times the derivative of the bottom. So that's, I've got to be careful with my signs, minus the top times the bottom, which is minus sign, so plus sign. But there's a minus in the front. I'm going to leave it like this so I can differentiate again. Sectan. Second derivative, 90 x power 8 minus the bottom squared, the bottom times the root of the top, so that makes it a cube then, minus the top, which is sine x, times the root of the bottom, which is 2 cos minus sine. So it's a square there. Now let's simplify this. So that's 90 x power 8 minus cos cubed over cos power 4. So that's cos x minus 2 sine squared x over cos cubed x. So lastly now, the third derivative. Oh man. 720 x power 7 minus cos squared. Bottom times the top minus the top times the bottom. Minus 2, we'll take that out. And then it's the bottom squared. The bottom times the root of the top, which is 2 sine cos. 2 sine cos minus the top, 2 sine squared x, times the root of the bottom, which is cos cos cos. So it's a product rule. So if you think about it, cos 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 will become minus sine cos cos minus cos sine cos minus cos cos sine. So there's 3 identical terms here, so I can take the minus 3 out and make that a plus 6. And it's cos squared by a sine, so that will become a cubed. So that will be 720 x power 7 minus sine over cos, which is tan x, and then 1 over cos, which is sec x. And this 2 is times all that, so that would be minus 4 sine x over cos squared x minus 12 sine cubed x over cos 4x. Oh man, I hope this is going to be right. 720 x power 7 minus tan x sec x minus 4 sine over cos is tan times cos, which is sec x, minus 12 sine cubed over cos cubed would be tan cubed, leaving me with a 1 over cos, which is sec x. So it's kind of cubic and tan. Oh, I'm nervous. 720 x power 7, check. 5 tan x sec cube. No. Tan cube sec x. No. No. Tragedy. Unless I can simplify things here. Maybe I can keep going. Because I have a tan in these two. Oh yeah, sorry, these tan sec, so that's minus 5 tan sec. Yeah, okay. So sorry, I could have added more together. 720 x power 7 minus 5 tan x sec x minus 12. Okay, the 12 is the problem. Because the answer does not have a 12 in it. So how did I get the 12? This is where there's a problem. That 12 was there. And that 12 was there. And that 12 was that 2 times that 6. And that 6 was there because it was the top times the root of the bottom. Why was it 6 and not 3? Was there a 2 here? Yeah, it's the 2 on the top. So, I feel like they forgot the 12. Let me pause and check the errata list to see if this is noted. Oh, it's not listed. It's not listed. So either I made a mistake with the 6, or they just forgot the 12. Really feel like they forgot the 12. Is there any way I could check for sure? If I open up my software, it might not express the answer the way I need it. What I could do is graph their answer and my answer and see if they match. That's probably going to be the best thing to do. Okay, so their answer is 720 x power 7. Well, I don't mean graph my answer and their answer. Let me just type in their answer. 720 x power 7 minus 5 tan x sec x cubed minus tan x cubed sec x plot. Right. Now, back to the question. X tan minus sec x. Okay. X power 10 minus sec x. Let's differentiate that 3 times. And plot this. So, if they're right, this plot should match up with their answer at the back. Ah, they're right, which means I'm wrong. Unless there's a tiny chance this this works as well. That would be extremely wishful thinking. Ooh, it's off a little bit. All right, I done screw up. Okay. Okay. Looks okay. Okay, bottom squared. Bottom times root of the top minus the top times root of the bottom. Okay. Then the bottom squared, the bottom times root of the top. Cos squared. Yeah, minus the top times root of the bottom. 2 there. 90, okay. Okay, the 2 is there. Okay, so the 2 is there. I took the 2 out. Still, okay, so I took the 2 out. And so let's just focus on this now. The bottom squared, the bottom times are the top, which reintroduces the 2. So what on earth is going on here? How is it that 12 is wrong? Okay, that's theirs. And then differentiate. No, that's mine. So maybe I need to see what's happening step by step. Okay, one derivative. Okay, there's the 6. There's a 6 there. One derivative. Okay, let's check that. 10x9 minus sine over cos squared. So we're okay to here. All right. A derivative again. Okay. 90x. Sign mistake. Minus a derivative mistake. Cos cubed over cos 4 is 1 over cos. Where's the sign gone? And then here, minus 2 over cos cubed. So, okay, something fishy has gone on here. I made a mistake. made a mistake. So maybe it would be worth going and fixing it from there. Okay. So what did I do wrong? I do not know. Second derivative. That's 90 x8 minus the bottom squared. The bottom times the derivative of the top. Sine becomes cos. Minus the top times the derivative of the bottom. And cos squared is cos cos. That'll become minus sine cos minus cos sine minus 2 sine cos. So that'll become plus 2 sine squared cos. So if you simplify that, you get 90x power 8 minus 1 over cos x minus 2 sine squared x over cos x. That's what I said, isn't it? So that's a little bit different to what we have here, but let's see if it's the same thing. 90x power 8 minus 1 over cos x minus 2 sine x squared over cos x. I'm not so sure about the square. Okay, it is fine. Let me plot that. Okay, that's my one. And then let me plot their one. Ah, okay, I'm making some stupid mistake here. On this step. What on earth am I doing wrong here? The bottom squared. The bottom times the root of the top. So that's a cubed. Minus the top, which is sine x, times the derivative of the bottom, which is 2 cos x sine x with a minus. So that's 90 x power 8 minus 1 over cos x. And then, oh, what is going wrong? Plus 2 sine is sine squared. And then cos cubed. 90. Oh, sorry, I didn't write in the cubed here. So actually, I could still be right. Okay, so that's my answer. And then that's their answer. Yeah, okay, good. Okay, it's equivalent. So we're okay. We're okay. So now on to the last step. 720 x power 7 minus cos squared x. It's the top times root to the bottom. Okay, plus. Let's be super careful here. And we'll put the 2 with the top. The bottom squared. The bottom times the root of the top, like I was saying earlier. And the root of the top will be 4 sine x cos x minus the top times the root of the bottom, which will be 3 cos squared x minus sine x. So that would be 720 x power 7 minus sine over cos is tan x And then 1 over cos is sec x. And then here you have a cos, that's a cos 4. So hang on, it's going to be plus 4 sine x. Well, actually, sine over cos makes a tan. So I can get rid of one of the cos's. So that's a 5. And then 3 and 4 is this. 3 and 1 is 4. And that's a 5. So there's a cos in the denominator. So that makes it a sec. Okay, so that's good. Because that makes it the... is it the minus 5 we need here? No, I've made a sign mistake. Did I lose a minus here? I just feel like I lost a minus. Minus 5. No, minus x tan x sec x. Oh dear, Stephen, you're having a bad day. I've been way over time. Yeah, way over time struggling with this. Wish I wasn't so tired. Tan sec. Is there even a tan sec in the answer? The sec cubed. Just push on, Stephen. Sine over cos is tan x. 1 over cos is sec x. And then there's a 4. Sine over cos is tan x. So that's down to 5. And there's 4 cos's on the top. So there's another sec x. And then here, what have we got? 6. 2 and 3 is 6. And we have a sine cubed and a cos 6. So we could make a tan cubed x. So we've taken care of the sine and the sine. There's 3 left down below. And the cos, so sec. So 6. Okay, so I have 720 x power 7 plus 3 tan x sec x plus 6 tan cubed x sec x. Man, oh man. Let's hope this matches. This matches. No, of course not. Way off. We know that this is okay. So that looks okay. That looks okay too. So something gone wrong here. The bottom squared. The bottom times root of the top, which is 4 sine cos. That looks all right. And then minus the top, which is 2 sine squared, times root of the bottom, which is 3 cos squared minus sine x. So what am I doing wrong here? So sine over cos makes a tan. And that will bring you to cos 5. And cos cubed and cos is cos 4. Cos 4 over cos 5 leaves a cos down below. So that's a sec. And then what is gone wrong here? I'm losing my mind. Absolutely losing. I'm going to pause. So upon further inspection, this is actually not okay. So I've made some mistake here. Bloomin', sign mistake. Bloomin' sign mistakes driving me nuts now at this point. Back in time we go again. Sick and tired of this last question. Sick and tired of it. Minus bottom squared. The bottom times the derivative of the top minus the top times the derivative of the bottom, which is 2 cos x minus sine x. So that would be 90 x power 8 minus 1 over cos x minus 2 sine squared x over cos cubed x. Now that's probably... Okay, so that is a sign mistake. So that's my answer. And that is the correct set. Okay, so this is okay, except for the sign mistake. So now let's get the third derivative. I really want this to be right. 720x7 minus the bottom squared. The bottom times the root of the top minus the top times the root of the bottom. Bottom squared. The bottom times the root of the top minus the top times the root of the bottom. Plus. So that is 720 x power 7 minus sine over cos is tan and 1 over cos is sec minus 4 sine over cos is tan, 3 cos cubed times a cos is cos 4 over cos 5 is 1 over cos, which is sec. Minus 6 sine squared times sine is sine cubed over cos cubed is tan cubed, and then cos squared over cos cubed, that's sec. So that's 720 x power 7 minus 5 tan x sec x minus 6 tan cubed x sec x. Is that right? Let us find out. (720) x power 7 minus 5 tan x sec x minus 6 tan x cubed sec x. I don't feel this is right. Yes. Yes. Goodbye.